We're now going to take a look at the algorithm for division of whole numbers. It's probably the most complicated procedure in elementary mathematics. And because of calculators, was kind of the importance of long division is kind of diminished. However, we still want students thinking about 1- and 2-digit divisors, right? Since it's kind of commonplace what we do in the world here. And the main idea behind our long division, our algorithm for long division, is that what's called the division algorithm we studied earlier, right? Which states that if A and B, so it's the division algorithm that we're looking at here. That again states if A and B are any numbers, then there exists unique numbers Q and R, which are the quotient and remainder, where A is equal to B, the divisor, times the quotient plus the remainder. And that's really where the long division algorithm comes from. And so let's think about, let's look at the quotient, right? Let's find the quotient for 461 divided by 3. And so long division, what you would do is, right, you say, how many times does 3 go into 4? You say 1, and you bring the 3, 1, and then 6. How many times does 3 go into 16? You say 5, 15, bring the 1 and 1. How many times does 3 go into 11? You say 3. 3 times 3 is 9. Remainder 2, right? And so what we learn is that 461 is equal to 3 times 153 plus 2, right? So you have the divisor times the quotient plus the remainder. Now we want to look at with base blocks. What's really happening is, what does division mean? It's really trying to divide 461 into groups of size 3, right? So as you notice here, you have 3 groups, and what we're going to do is we're going to break this up here. And so here are your hundreds, and that's the first thing we're looking at. We have 4 hundreds. And so the algorithm's really saying how many of these hundreds go into here. And so out of the 4, each group would get 1. And so I'm left with that. But then what you're left with really is a 161, if you really think about it, right? There's your 161. And so then what we're now asking is how many tens can fit into each of these. So you have your 6, but then this here gets broken down into your tens, right? And so now you have 16 tens. And so what happens is that each of these gets 5 of them, because there's 16. Each of them gets 5. And so you can then see, once everyone gets 5 of them out of the 16, you've eliminated these, you eliminated these, you're down to 1, you're down to 10 here. Now you have 11. How can I break 11 into 3 groups? That means each group gets 3. Each group is getting 3, and then what you end up with is you have these 2 left over here, and that's your remainder 2. And that's really what the division algorithm's doing. When we do this here, that's how it's being broken down. So again, you're going to practice. You've done long division before. It's really just this idea of where does it come from, and it comes from this idea of base blocks and breaking up and dividing into equal groups, and then you start with the big one and continue down to your ones. That's where that comes from. You'll practice that more. We want to introduce you to another method called the scaffold method of division. And sometimes this is interesting for younger children to learn, because these problems are hard to do. It's hard to figure out how many times does 3 go into 51? How many times does it go into different numbers, right? Whatever your divisor is. So in this case, on the scaffold method, what's happening is you don't ask yourself how many, like to try to find the exact number. You just estimate. So for example, 5739 divided by 31. That's a hard problem to do, long division, because what is going to happen is a student has to answer this question here, right? How many times does 31 go into 57? That one we can do, it's one time, but it's not always easy to do. You end up with the 6 and 3. How many times does 31 go into 63? I think that's 2, right? So that works. That's what you were doing. But another way to do this would be, how many times does 31 go into this number? I don't know, but I know it goes into it 100 times for sure. So you just do 31 times 100, write 31, and subtract. And then you get a new number, 51. How many times does 3100 go into 1550? I don't know. I know it's not 100, but 50 is a good estimate, right? And so then, how many times does 31 go into 2639? And you say 50 times, because I know at least half of that, right? And so then you get that. And we're just using compatible numbers. That's all we're using as we continue to subtract. And then you have 1089. And then you say, how many times does 31 go into 1089? Notice, right? Let's guess. 30? Yeah, 30 works. 930. How many times does 31 go into 159? 5 times. There you go. And you end up with your answer. So you end up getting 185 remainder 4. It's a lot more work, but it's systematic versus I see students do a problem like this and they have a whole bunch of multiplications on the side trying to figure out the exact number. Here, the advantage is I don't need an exact number. Let's finish this section on another example. 4238 divided by 56. Here's the long division, right? What's happening is you're trying to decide how many times does 56 go into 42? It doesn't. How many times does 56 go into 423? And then you do all these little computations on the side to try to calculate, right? Get the exact number. An alternative would be the scaffold method, and that's what we'll do here. So we ask ourselves the question, how many times does 56 go into this? I don't know exactly, but I know it doesn't go 100 because that's too big. But I'm going to say I think it goes at least 56 times, right? And so in this case here, I'm going to do 50 times 56. And so to get that answer, that's going to be 50 times 5. Okay. So we can have 50 times, this turns out I can do this calculation in my head. 50 times 6 like that, right? 50 times, so it's 2,500 plus 300. So this turns out to be 2,800. So I know at least 50 times, okay? And so then that's 2,800. You subtract, that's a 3. 12 minus 8 is 4. This is a 3. So it's now I have 1,438 left, but I used 50 already. Now, how many times does 56 go into there? I don't know, but I'm going to just use 10, and that gives me 560. So I'm using 10 because I can calculate that one easy. 8, and again, it's compatible numbers I can use. And let's subtract the 560. That's 7. This is an 8 now. This can't, I had to borrow, so then that's 3, 1, or regroup, sorry. 13 minus 5 is 8. How many times does 560 go into 878? I know for sure 56. So that's your 560. And then there's your 8 again, and 1. And so then we have the 1 here, and then this is 3. How many times does 56 go into, how many times does 56 go into 318? I think 5 for sure. And so that would give me half of this here, 250 plus 30. So that's 280, and so I can subtract 280. I get 8, 11, 3, and it's more steps, but again, I don't have to find the exact numbers. and I'm going through a process, kind of a repeated subtraction. That's what you're going through. And so then you end up with, add this up, 50, 60, 70, 75, remainder 38, which is the same answer we got here. So be mindful of scaffold method for sure. I'll ask you that you're going to want to be able to learn how to do.